Consider the curve y equals 2x third power minus 9x squared plus 12x plus 2 for x greater than equal to -1, less than or equal to 3. Find its gradient function. Y prime equals 2x to the third power prime minus 9x squared prime plus 12x prime plus 2 prime. M times x to the nth power prime equals m times n x to the n minus 1th power. X squared prime equals 2x. X prime equals 1. Constant number prime equals 0. So we have 2 times 3x squared minus 9 times 2x plus 12, then plus 0 equals 6x squared minus 18x plus 12. For second question, find all stationary points by the first derivative of function. Y prime equals 0, which means 6x squared minus 18x plus 12 equals 0. By solver, put a derivative function into y1, math, upper arrow, solver, alpha trace, y1, enter, put a 10 as the estimated value, alpha, enter. Answer is 2. -10, alpha, enter. Answer is 1. You can also get x-intercepts by graphing. x1 equals 1, x2 equals 2. Substitute 1 and 2 into original function to figure out the y-coordinate for all stationary points. We put original function into y2, then quit. Alpha trace, go to y2, enter. Parenthesis 1, we do the substitution. We get 7. Alpha trace, y2, we put 2, enter, we get 6. The coordinates for stationary points is 1, 7, 2, 6. Question 3. Classify all the stationary points. We know f prime of x equals 6x squared minus 18x plus 12. Let's draw the table. X and f prime of x. 1 minus 0.1, 1 plus 0.1. We will use these two tables to classify the stationary points. Derivative function is y1. We got to use y1. Alpha trace y1. Put 1 minus 0.1. Enter. It's a positive. Alpha trace y1. Y of 1 is 0 because stationary points at x equals 1. Let's go to y1 of 1 plus 0.1. positive, 0, negative. Then we can sketch the diagram. Positive means increasing function. Then stop at x equals 1. Then decreasing. So 1, 7 is the local maximum point. In other words, 7 is a local maximum value. Let's check the point 2, 6. Alpha trace y1, 2 minus 0.1. Enter. Negative. Alpha trace y1, parentheses 2 plus 0.1. Enter. It's a positive. Negative, positive. Decreasing. Then increasing. Which means 2, 6 is a local minimum. Or 6 is a local minimum value. For number 4, find the absolute maximum and absolute minimum points. We call this is a boundary points. Find the f of -1 and f of 3. Then compare to the local maximum or local minimum points to figure out absolute maximum or absolute minimum points. For the boundary points, f of -1, f of 3. We already know the local maximum is 1, 7. Local minimum is 2, 6. Remember, y2 is the original function. So go to y2. Substitute -1 into original function, we get -21. Alpha trace y2, parentheses 3. Enter. 11. So we get boundary points -1, -21, 3, 11. Let's compare 2 stationary points and 2 boundary points. So -1, -21 is the absolute minimum point, and 3, 11 is the absolute maximum point. Let's go to number 5. Find the interval where function is increasing or decreasing. We only need a derivative of function graph. So unhighlight this y2 graph. Then above x-axis is a positive, below x-axis is a negative. 1, 2, positive, negative, positive. For f prime of x, 1, 2, positive, negative, positive. This part increasing, decreasing, increasing. Negative infinity, positive infinity. Negative infinity to 1, union. 2 to positive infinity. F of x is increasing. From 1 to 2, f of x is decreasing.